All right, let's go over one of our first equations for energy, and that is the equation for kinetic energy. So I want to remind you that kinetic energy, or it abbreviated as KE, is the energy due to motion. So if you have motion, if you are moving, you're going to have some kinetic energy. All right, and if you've ever been hit by something that was moving, you feel that kinetic energy when it hits you, and it can hurt pretty bad. Our equation for kinetic energy is right here. Kinetic energy is going to be equal to 0.5 of your mass times your velocity squared. All right, and I have each of the variables defined for you right here with their standard units. So if you want to pause the video and write this down, that would be a good idea because we're going to go through an example problem. All right, so our first example is right here. We've got a 60 kilogram jogger, and that jogger is running at a velocity of 6 meters per second. How much kinetic energy does the jogger have? So just like normal, I am going to go through and I'm going to first identify what the question is asking me for. The question is right here, and that's a really big line. The question is asking me how much kinetic energy. All right, so I am looking for KE. Now that I know what I want, I'm going to go back through the question and solve or look to see what information I was given. A 60 kilogram jogger. This is telling me the mass of my object, of the jogger. All right, so my mass is 60 kilograms. And what is this jogger doing? Well, they're jogging, they're running. And they're running at a velocity of 6 meters per second. So that is going to be my velocity, my speed. All right. V equals 6 meters per second. All right, so I've got all of the information in here. Let's put it into a list. My KE is unknown. My mass is 60 kilograms. And my velocity is 6 meters per second. Now, a lot of you probably could solve this without my help, but I'm going to go through it anyways. So, KE equals 0.5 times m times v squared. All right. We do not know KE, so I'm going to leave that as KE. I'm going to bring down the 0.5. I do know my mass, it is 60. And I know my velocity, it's 6. But the 6 is squared. Don't forget to square. A lot of people do. All right. So all I'm going to do is type this into my calculator. This right here, I can put the whole thing into my calculator at once, so let's do that. 0.5 times 60 times 6, and I'm just going to multiply by 6 twice because that's the same thing as squaring. I get 1,080 joules. All right, so my KE is 1,080 joules of energy. So just from this jogger running, so he's moving, just from him moving, he has this much energy if he's running at this speed. All right, because your kinetic energy, the amount of energy you have due to motion, is dependent on your mass and is dependent on your velocity. So if you change one of those, if he were to speed up, his kinetic energy would go up. And if he were to slow down, his kinetic energy would go down. He could also change his mass to change his kinetic energy, but that's a lot harder to do unless he were to like poop as he was running. Then his mass would change a little bit. His kinetic energy would go down because he would lose mass. Otherwise, in the next video, we're going to look at one where we're solving for something else.